Solving systems of equations.
If you have a system of linear equations like this, there's two methods you can use to solve it: elimination and substitution. Let's look at elimination first. If both of your equations are in standard form, the easiest method to use is elimination. Your goal in elimination is to cancel one of the variables. If you can get rid of one, you can solve for the other and then plug it back in. So here it's already set up for us. We have negative 4x and 4x. So we can, if we add our two equations together, we can cancel these and we'll be left with only y's. So 8 minus 2 is 6, so we have 6y, and that is going to be equal to negative 36. If we divide both sides by 6, then we'll get y is equal to negative 6. And then we can plug that back in to our original equation. So let's plug it into the first one up here. And that will be, so we will have negative 4x minus 2 times negative 6 is equal to negative 12, and we need to solve for x. So this is going to be negative 2 times negative 6 is 12, and so we'll have a positive 12 and a negative 4x plus 12. So now we can subtract 12 on both sides. So negative 12 minus 12 would be negative 24. So we would have negative 4x is equal to negative 24. Divide both sides by negative 4, and we'll be left with x is equal to negative 6. So our coordinate point where these two lines intersect is negative 6, comma negative 6. Here, neither of our equations is set up for elimination. So we need to multiply both of our equations to make it where we can cancel one of the variables. So let's cancel out y. We can multiply the top equation by negative 5 and the bottom one by 2. And we'll have negative 15x plus 10y is equal to negative 10. 2 times 5x is 10x. 2 times negative 5y would be negative 10y. And 2 times 10 would be equal to 20. So now if we add these, our y's will eliminate. And 10 minus 15x is going to be negative 5x. That will be equal to 20 minus 10, which is 10. If we divide both sides by negative 5, x is equal to negative 2. And now we can plug negative 2 back into our original equation, and we'll have 3 times negative 2 minus 2y is equal to 2. 3 times negative 2 is negative 6, and if we, so we all have negative 6 minus 2y is equal to 2. We can add 6 to both sides, and we'll have negative 2y is equal to 8. Divide by negative 2, y is equal to negative 4. So our solution is negative 2, comma, negative 4. Substitution is usually used when you already have one of the variables solved for, or when you have one of them in slope-intercept form. Obviously, if you have both of them in standard form, you can solve for one of the variables and substitute it in, but here we already have one of our variables, which is y, so we'll just plug it in here. So we'll have 4x minus 3 times negative 2 is equal to 18. Negative 3 times negative 2 is 6, and we can bring down our 4x plus 6 is equal to 18. Subtract 6 from both sides. We'll get 4x is equal to 12. If we scroll down a little bit and divide both sides by 4, we will get, let me switch up my color, x is equal to 3. And we already have our y.
Let's try another example. Here we have 2x minus 3y is equal to negative 1, and x is equal to y plus 1. So we don't actually have one of the variables solved outright, but we do have an equation for it that we can substitute into our other equation. So if we know x is equal to y plus 1, we can just substitute this x for y plus 1. So let's do that. We have 2 times y plus 1 minus 3y is equal to negative 1. Let's solve. I'm going to do this in pink. So we have 2y plus 2 minus 3y is equal to negative 1. We subtract 2 from both sides, and we can also combine our variables here. So 2y minus 3y is going to be negative 1y. So we have negative y is equal to negative 3. We can multiply both sides by negative 1, and we will find that y is equal to 3. And now we can put this 3 into our equation for x here, and if we do that, we'll have x is equal to 3 plus 1. 3 plus 1 is 4, so our x is equal to 4. So our final answer would be 4, 3. Let's try a word problem. Here we have Mr. Fettuccine, and he just started a pasta restaurant where he makes tortellini. If Mr. Fettuccine invests $5,000 into equipment, and it costs $5 to make each pound of tortellini, and they sell each pound for $10. So if they make 20 pounds a day and sell all of them, how long until they start making a profit? So if it costs $5 to make it and they are making 20 a day, then each day they are spending 20 times $5 a day, which is $100. And let's use X for days. And then we have to add our initial cost of $5,000. So add 5,000, and then they sell it for 10. So 10 times 20, do that in pink, 10 times 20 is going to be equal to 200. So they're bringing in $200 a day from their pasta, so it would be 200x. So let's rewrite this with some y's. Y is equal to 100. Actually, let's divide everything by 100 to make it simpler. So we'll have y is equal to x plus 50, and we'll have y is equal to 2x. So here are our two equations, and as we can see, both of them are equal to y. So we can just set them equal to each other. So we'll have x plus 50 is equal to 2x. And we can subtract an x on both sides, and we'll find that x is equal to 50. So it's going to take 50 days for them to start making a profit. Let's find out how much money they have to make. So we plug in our 50. Let's just use our simpler equation here. We'll have y is equal to 2 times 50, is going to be equal to 100. And then remember, we divided everything by 100, so we need to multiply this by 100 times 100. So 100 times 100 is 10,000. Final y value is going to be 10,000. And the reason we don't have to multiply this 50 by 100 as well is because we divided this entire expression, which is y, we just divided y by 100 at the start, and we didn't actually divide our x by 100. It will take 50 days for them to start making a profit, and they'll have to bring in $10,000.